Okay, so back to some of the endocrine glands. I want to spend quite a bit of time talking about the hypothalamic pituitary pathways. However, before that, I want to make sure you have a good understanding of the simpler pathways. So just like we saw with the control systems, when an endocrine organ is both the sensor and the integrator, and it's the only endocrine organ involved in some initiating a response. So this is a really important component of the endocrine system, and we'll see it other times this semester. For example, even organs that aren't endocrine organs, so the kidneys responding to some signal and then releasing hormone to cause a response based on the signal they are directly receiving. This is a really important part of endocrine function. So a couple of examples of these kind of simpler pathways before we get into what we're going to spend most of our time on, which is more complex. So here's one example that you've seen before of this idea of one endocrine organ is involved, right, in the response to, in this case, low plasma calcium is what's shown here first. There's a different response to high plasma calcium. So parathyroid, we've seen this before. You did learn this in the fall. So we've got low calcium in the blood. Our parathyroid gland, not just the left, but that's just what's next here, is going to detect directly that low calcium, and then release what? Release PTH, parathyroid hormone. This here is just showing the histology of the parathyroid gland, the cells that are detecting and then producing PTH. PTH is going to target the bone, intestines, and kidneys, which all have responses to increase calcium. Negative feedback loop, maintaining plasma calcium. Similar for high calcium. In this case, it's the thyroid gland that detects high calcium. Thyroid gland directly detects calcium in the blood. And then the parafollicular cells. So it's not that this is a kind of a secondary job of the thyroid, beyond what we will talk about more in this semester related to metabolism. Parafollicular cells release calcitonin, which target the bones to decrease calcium. So decrease bone breakdown. Details aren't as important here as this idea of a simple endocrine pathway. It's not actually simple in any regard, but one endocrine organ that's directly responding and then directly detecting and then initiating a response. One more example, we'll see this when we get to digestive system, is the pancreas. The pancreas responds to blood sugar, altered blood sugar levels. So high blood sugar, for example, would be detected by cells in the pancreas. These pancreatic cells are endocrine cells. So here we can go into more detail when we get to digestive, but these are the endocrine cells. There's also other cells that have digestive enzyme producing function. Endocrine cells are going to produce hormone in response to low blood sugar. This is going to be glucagon. I'm sorry, I have high written there. Since I have high blood sugar, yeah, it's going to be glucagon. I did have that right. Glucagon is the hormone that's going to target things like the liver to decrease blood glucose by converting glucose to glycogen. Similarly, we could have the opposite color. There we go. Low blood sugar results in insulin secretion which is going to also could target the liver to increase blood glucose by converting glycogen to glucose. Okay. Again, the details aren't as important here as this is one endocrine organ detecting and initiating a response. Because what we're going to do next is a lot more complicated. So we are going to talk about the hypothalamic pituitary pathways, and they are a lot more complex. So this is going to be hormones in the hypothalamus, which is in the brain, just below the thalamus, that are the hypothalamus is initiating hormone release from the pituitary, two different mechanisms in the anterior and posterior pituitary. Regardless, though, the result is hormone release from the pituitary gland that was initiated in the hypothalamus. So this is the hypothalamus has direct endocrine function. It's producing hormones. And just remember, this is in contrast, this is not the hypothalamus' only job. We've talked about the hypothalamus and its role in the autonomic nervous system. So initiates, contacts the spinal cord to both result in neural signaling directly onto target tissues, as well as contacts the adrenal medulla, again through the spinal cord. This is nervous system response. The adrenal medulla releases hormones, norepinephrine and epinephrine. So in that case, the hypothalamus is a control center for the autonomic nervous system, which indirectly results in endocrine hormone release. But its role in the ANS is not as an endocrine organ itself. There are responses where both of these systems respond in unison. So a stress response is something we'll talk about that results in sympathetic activation, sympathetic nervous system, as well as hormones from the anterior pituitary resulting in cortisol release, which is also a stress hormone for longer term stress. But there are other times where this hypothalamic pituitary pathway here is independent of the autonomic nervous system. They're not necessarily coordinated. Okay, so we're going to talk quite a bit coming up on hypothalamic pituitary pathways.